The story starts in 2024. This is me at FOSDEM conference, sitting in one of the talks, and the speaker started demonstrating a digital synthesizer. And the moment I heard that sound, I immediately said to myself, I need one of those. Now, a normal person would buy a synthesizer, but this is my excitement. We respect the difficult way. So instead of buying one, I decided to build a synthesizer from scratch. Despite knowing absolutely nothing about synthesizers, a fantastic decision. So before building the synth, I had to learn synthesizer itself. And honestly, Synthorial helped me a lot. Without it, this project would probably still sound like a microwave fighting with a printer. So if you also want to learn synthesis, you can use the link below to get a discount on Synthorial and their other products. I will also get a small benefit from it, which helps support projects like this and future bad decisions. After many hours of learning, I slowly upgraded from a random electronic screaming to slightly controlled electronic screaming progress. So I built the first prototype, a Teensy 4.1, a tiny touch screen and very basic oscillator. For the first version, I used pure data for handling the inputs. It was not bad, but it was a bit messy. But eventually I made sound. Then I made another dangerous decision. I decided to design a PCB with zero PCB experience, of course. Then I started routing the board, and honestly, the result looked like somebody dropped spaghetti onto motherboard. Eventually, I asked for help cleaning it up, and to be fair, it became cleaner. Smaller, not really, but emotionally smaller. Then one day the PCBs arrived, and suddenly the project became very real. Then it was time for soldering, and I would love to tell you this part was clean and professional, but truth is it was mostly controlled panic. But somehow it worked, and honestly I still don't fully trust that fact. Then came the firmware in C++. After almost 20 years away from C++, and apparently modern C++ involved while I wasn't looking, I remembered simple classes. Modern C++ responded with templates, build systems, libraries, and emotional damage. I used Platform IO or Platform U, whatever you call it, which was actually really fun. And then finally, I connected the MIDI keyboard, and suddenly I heard actual notes coming from my own synthesizer, which was amazing. But a synth without an enclosure is basically just organized panic on a desk. So I started designing the case. First Tinkercad, then FreeCAD, then Blender, then Fusion 360. And at some point I wasn't designing an enclosure anymore. I was just speedrunning emotional damage using CAD software. I printed version after version after version. Some didn't fit, some almost fit, some looked like modern art. But eventually, after many failed prints, I finally had a real enclosure. It was not the most beautiful one. And after around 2 years, Yottasynth was finally real. A touchscreen synthesizer, 5 context-sensitive knobs, a sequencer, an arpeggiator, custom hardware, custom firmware, and even support for Persian musical tuning. Yeah, that one is my favorite one, and I never saw it on any other synth. Let me show you how it looks. This is the play page, the main performance screen. 5 knobs always control whatever parameters are visible on the screen. So instead of having 50 physical knobs, I only needed 5, which is great because my PCB already suffered enough. This is oscillator page. This is where the synth sound starts. Then comes the filter page. Then modulation page adds movements. And here you can see effects, echo, reverb, and drive. The arpeggiator turns simple notes into patterns. Let me show you how it works. And this is the sequencer, 16 steps, pattern editing, live recording. And finally, the settings page included my favorite part that I was talking about, the Persian musical tuning, which gave the synth a sound and personality I really wanted it to have. Let me show you how it works. So if you like it, feel free to like the video and leave comments.